Okay, so we're going to look at another example, question 8 on the words into balanced equation sheet. And we've got three compounds here: sulfur 4 oxide reacting with oxygen to make sulfur 6 oxide. Now this is an example whereby sulfur, we're told, on the left hand side has a valency of 4. On the right hand side it has a valency of 6, which means that when it goes into its compound with oxygen in these two cases, sulfur in the first example, I would say, has a valency of 4, and in the second example it has a valency of 6, again reacting with oxygen. Oxygen's in group 6, so it's 2 electrons short of having that magic number of 8, which means it's got a valency of 2. We'll assume it's got a 2 in both cases. That then means we can cross our numbers over in the usual manner now. We end up with S2O4 and likewise S2O6. Now, because those numbers are divisible by each other, the 2 goes into 4 twice, so that allows us to cancel that down to S1O2. Okay, so simplify that formula down. Likewise, we can do that with this one. The 2 goes into 6 3 times, which then allows us to have a formula of SO3 on this side. Okay, so SO2 on the left-hand side, reacting to make SO3 on the right-hand side. Oxygen element on the periodic table of elements, but remember, it's one of these magic ones which has this number 2. So we just write the number 2 on. Okay, it's one of the gases. So we then have all of our symbols written, okay, all our formulae written, and we then leave those alone. Okay, we don't change any of the numbers within the formula. We just change the number of formulas that we have. And what we do in the first instance, as with any of these things, is add them up. See what we've got on both sides of the equation. We've got 1 sulfur. We've got 2 oxygens. Okay. We've also got another 2 oxygens. Now that gives us a slight issue, because what that does mean then is that cumulatively we've got 4 oxygens overall. On the right hand side we've got 1 sulfur and we've got 3 oxygens. The left-hand side is made slightly more difficult by having this double location of oxygen, but hopefully we'll get to that. On the right-hand side then, we've got fewer oxygens. The sulfur is actually okay. Okay, the sulfurs are actually okay. We've got 1 of each. It's the oxygen that's wrong. We've got fewer oxygens on the right-hand side, so we have to increase the number of oxygens on the right-hand side. Now, a trick, no rule that this thing exists, but whenever you see a number 3, sometimes it's easier just to magically double the number. Sometimes there's no evident reason for why we do that, but 3s are harder to look after in a balancing equation, I find. And if you can make that number become a 6, it's an even number. It just looks a lot nicer than a 3. You can divide it by 2. You can subsequently divide it by 3 if you need to, but 6s look nicer. And sometimes it magically helps you make the equation work. Ultimately, what that has done, though, is that has now damaged our sulfur. We can't now say that that equation is balanced with respect to sulfur. So what we're going to have to do is try to remedy that situation. We need to double up the number of sulfurs on this side and make that into a number 2. We do so by adding the number 2 to sulfur dioxide. That changes that to 2. Now, what that will also do is change the oxygen to 4. In changing the oxygen to 4, that's actually made this into a 6 as well. The evidently random way we double this has actually allowed us to much easier balance up